here's a probability problem that calculates the probability of some different things happening. And so we might call this the probability of independent events. So this problem, we have, if a single die is rolled 5 times, what is the probability that it lands on 3 on the first, second, third, and fourth rolls, but not on any of the other rolls? So what I'll do for the solution is I'm going to draw 5 blanks. The 5 blanks represent the 5 rolls. So I'll do blank, 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 blank. Under each blank, I'm going to put what that blank is. This is the first roll. This second blank is the second roll. The third blank is the third roll. The fourth blank is the fourth roll. And the fifth blank is the fifth roll of the die. Now I have a nice die here that I can use for this probability problem. And I'll roll it 5 times. And they want to know about certain things happening. So we roll it 5 times. What's the probability that it lands on 3 on the first, second, third, and fourth rolls, but not any of the other rolls? So as I look at the die, I have to look at it and say, well, the probability of 3, probability of getting a 3 on one roll, any one roll. Now, I'm not necessarily talking about the first roll right there, but the probability of getting a 3 is 1 over 6 because there's 1 3, but there are 6 different places, 6 different ways the die can land. So, since we want to know the probability of 3 on the first, second, third, and fourth rolls, what I'll do is underneath first roll, we want to know there the probability of 3. On that one roll, well, that is 1/6. So you put 1/6 in the first blank. And then it also said 3 on the second roll. Well, a probability of 3 on the second roll is 1 over 6. The probability of 3 on the third roll is 1 over 6. And the probability of 3 on the fourth roll is 1 over 6. Now, if these are independent events. What I mean by that is I roll it once. I kind of cheated. I made sure it landed on a 3. There's my first roll. I pick it up and I roll again. And what happens on the second roll had nothing to do with what happens on the first roll. That means they're independent events. When we have independent events, we're actually going to multiply these probabilities together. The first roll, second roll, third roll, fourth roll, fifth roll. The fifth roll is not a 3. It's not a 3 on any of the other rolls. The only roll left is the fifth roll. But as I look at the die, not a 3. Well, it could be a 1. It could be a 2. Not 3. It could be 4, 5, or 6. There are 5 things that would be not a 3. So maybe here I also want to make a comment. Probability of not a 3 is 5 over 6. So that's the number that's going to go in the fifth blank, the fifth roll. So as I look at this, I need to multiply the numerators. 1 times 1 times 1 times 1 times 5. So the numerator on my answer is going to be 5. Now the denominator will be 6 times 6 times 6 times 6 times 6. On your calculator, you can just go 6 raised to the 5th power, and I get 7776. So my answer is 5 over 7776. And you might want to check to see if that can reduce. Well, this cannot reduce. The top would only reduce by 5, and since the bottom number ends in a 6, that does not reduce by 5. To reduce by 5, it would have to end in a 5 or a 0.